We've talked about how an interpreter needs a list of operators, weights, and other information to run a model. But how is this data stored? The model format is the link between training a model and running it on a device. So in this video, I'm going to run through the format and how we'll use it. If you look near the start of the Hello World sketch, you'll see this section of code. This is how we set up the model data structure. The most important call in this line, the g_model variable, is an array of bytes that we have exported from TensorFlow, held as a C array in a source file. This array of bytes is the raw data of the model. And the get model returns a C++ class that lets us access the model's data element. As the comment mentions, this call doesn't do any data movement or copying, so it's very memory efficient. It just creates a thin wrapper to read the information in place. Once we have this C++ class, we can read the operators and weights to understand how to run the model calculations. The underlying bytes of the model are stored in a read-only array, which means it can be held in flash memory, not in RAM, but in flash memory on devices that have it. If you're used to programming desktop computers, you can think of this array as bytes as equivalent to of a file on a disk. But since embedded systems don't have file systems, we store the data in read-only memory or in ROM. Serialization into a byte stream turns the data structure in a language like Python into a form that can be stored as an array of bytes and then understood by other languages. So actually we can store it, export it from Python, but then consume it and operate on it in C++. You might be familiar to other ways of serializing data like JSON or protobufers. For TensorFlow Lite Micro, we are using flat buffers. And the key reason is that they are very memory efficient. This matters because there's often very little memory available. Typical embedded chip might have only megabyte of flash memory and 256 kilobytes of SRAM. This means that we need a library to use very little memory and doesn't need an operating system support. And so that's often left out to save on space. So we have this model stored as an array of bytes, the equivalent of a file. And that holds all the information that we need about a machine learning model. The flat buffers format allows us to keep that information in place without needing any additional memory, and also has the benefit of not requiring any operating system support, as we mentioned before. The serialization format is defined as a text file called a schema. And this specifies what elements are held within the data structure and where each are placed. The flat buffer compiles the schema definition and creates C++ code to access all the data held in a serializable byte array. To give you an idea of what's held in the model data, the main parts are metadata about the model, like the version, quantization, inputs, and outputs. Then also a list of operators to perform, and then the size and value of all the weights. If you want to get a better feel of what's inside a flat buffer model structure, we've created a collab that lets you explore reading, modifying, and writing out a model in Python. And that will let you change the stored weights, for example.